In this video, I'll show you how to solve the ALEKS problem called Calculating Formal Charge. This problem is going to give you a Lewis structure and it'll ask you to calculate the formal charge of every single atom in the Lewis structure. There are a couple of different definitions of how we calculate the formal charge, but the one that I like to use is to take the number of valence electrons for an atom, subtract the number of bonds that are around that atom, and then subtract the number of electrons that are in lone pairs. So I'm just going to call those non-bonding electrons. Non-bonding. And for bonds, if you have a double bond, it counts as 2. If you have a triple bond, it counts as 3. Now, again, there are different variations of how this equation is written, but if you look at them closely, they're all saying the exact same thing. They're all giving you the exact same result at the end. So we're going to need to know how many valence electrons are in each atom. And on this periodic table, I'm just marking the number of valence electrons for each atom. Remember, in the noble gas column, things are kind of weird. Helium has 2, but everything else has 8. So in general, it follows a nice pattern: 1, 2, 3, 4, 5, 6, 7, 8. So let's just go ahead and take a look at each one of these. I'm just going to start at the top of this Lewis structure and work my way down. For chlorine, which is located right here, that is in column number 7, so that means it has a total of 7 valence electrons. From that, we're going to subtract the number of bonds that are around this chlorine atom, which is just 1. It has 1 bond. And then from that, we're going to subtract the number of non-bonding electrons. That is 1, 2, 3, 4, 5, 6. 7 minus 1 minus 6, that's a formal charge of 0, and this would be the top chlorine, so that's going to be a 0. Now let's just kind of work our way clockwise. Here's our next chlorine, and if you look at this chlorine closely, compare it to the first one that we did, you'll see that they're exactly the same in terms of what I'm going to call their bonding environment. They're both chlorines, obviously, so that means this is going to be the same. They both have 1 single bond, so that part would be the same. And they both have 3 lone pairs, which means that they're going to end up having the exact same formal charge. That is the chlorine on the right. That's a formal charge of 0. And then if we keep looking, ALEKS kind of gave us an easy problem here. All of the chlorines are exactly the same. They all have the exact same bonding environment. So we don't need to recalculate for every single one of these chlorines because they are all exactly the same. So now let's do the phosphorus. We need to locate phosphorus on the periodic table. It's right here. It has a total of 5 valence electrons. Next, we want to look at how many bonds are around the phosphorus. The phosphorus has 1, 2, 3, 4 bonds. And then the number of non-bonding electrons around the phosphorus, it does not have any. So that is a formal charge of +1. And we'll fill that into this box. Now, one thing that's kind of weird about formal charge versus like cation, anion charge, if we're writing formal charge, we write the sign first followed by the magnitude. So this is kind of different because if we were writing the charge on an ion, sodium is not a good example. If we're writing the charge on an ion, we write the magnitude first followed by whether it's positive or negative. But when we're doing formal charge, we write the positive or negative sign first and we follow it by 1. Also with formal charge, and we don't ever leave the 1 out. So we wouldn't say that a formal charge is plus. We always say +1 or -1. Now, one last thing that you can do to double check your work to make sure that you haven't made a mistake, if you add up all of the formal charges that you have calculated, which I add that up to +1, that needs to match up with the overall charge on your molecule or ion, which it does.